Hello, everyone. Get started here in just a second. Just giving everybody a minute to join. Just turned on the stream. If you saw part one, then thanks for coming back for part two. I'm hoping that today's is going to be a little bit more exciting than last time's. Just giving myself a minute to get everything set up. You can watch this on either Twitch or on Twitch TV /NBLenore, or you can find it on my Twitter via Periscope. So I will be doing my best to keep an eye on both chats throughout the course of the stream, but if you're putting something in the chat and I haven't replied to you yet, just give me a minute and I will make sure to get to you. Okay. Almost got this here. Okay, well, let's get to it. So last time I was streaming, we started with putting down all the resistors, and I was talking a little bit about what this thing does. Typically, I'm like working on guitar pedals, or I'm like building a Eurorack module, but I really wanted a piece of hardware that would let me actually test Eurorack modules at my bench, debug them, have some diagnostic capabilities, especially to allow me to tune oscillators and things like that without having to have my whole Eurorack kit in here with the keyboard. Anyways, this is the Eurorack Synth Noodle Toaster V2. If you check out the description, there'll be a link. I'll drop a link to this in the chats right now. And this is made by a gentleman out of the UK from AmazingSynth.com. He has a bunch of cool stuff on here, but this in particular is a pretty neat build that will allow me to do everything I'm going to need to do with regards to Eurorack module debugging and testing on my bench with my scope, and not be running back and forth to my studio versus the lab as I'm working on things. So let's go ahead and get on to the build part of this. So when we stopped last time, I had just gotten to placing all the resistors and kind of talking through everything, but I hadn't started to place any of the more interesting components. The screen, the chips, the transistors, and getting it all up and running. So I'm hoping this time will be a lot more entertaining because I'll actually be able to, I'm hoping to be able to get through all of the remaining parts and then do some initial bring up and see if the board is working or if we made any mistakes. We're going to start with kind of simple components first though. So I'm going to leave the chips and all of the knobs and etc. for the last step, and we're going to focus next on capacitors. So this thing doesn't really have a build guide. There's a website with some additional information, and you just get the board, which is pretty well silk-screened with regards to, you know, what the value of the part is and the polarization and so on. So let's kind of just start going through the board here. Last time I was trying to like group them into groups of parts because I knew I would have a lot of a certain resistor. This time I'm just going to start, from, let's see, let's do this clockwise. So I'm going to start from 12 o'clock and work my way around. So the first part we have is a 100 nanofarad capacitor. It looks like an NLCC capacitor. It's certainly not electrolytic. So to give some background, like I'm not an electronics expert. I don't do electronic engineering for a living. I have been doing it as a hobbyist and also doing vintage synth repair and restoration for quite a few years now. And so when I'm kind of talking through what I'm doing in my thought process and workflow, it's going to be in the, it's intended to be in the capacity of a hobbyist plus doing this stuff. If you notice that maybe I could describe something a bit better and you have expertise in electrical engineering, please feel free to drop a note into the chat, and I'll do my best to make sure that the information I'm given is as accurate as possible. Okay, so this is 100 nanofarad. Just double checking my conversion here. Okay, so that's going to be a 0.1 microfarad. So it's not this, it might be these. Yep, this is it. So, stop it here. So last time we had to do a lot of kind of obnoxious lead forming, but this time I'm hoping that things are going to line up a lot easier. This is a MLCC, a multi-layer ceramic capacitor. It's not polarized, so I'm not particularly worried about what direction it's going in the board. And once again, we're going to be using unleaded solder. So this, I'm still getting the hang of exactly the technique with working with this stuff. I wish it worked, honestly, as well as leaded solder. It certainly does not. But so far, I've managed to get acceptable results. We'll see how this holds up over time. One of the things I've noticed with the pads on this board is even with some flux, sometimes it's a bit hard for me to get the actual pad on the board to alloy with the solder and make a good joint. It tends to just get clumped up on the lead. So I'm trying to be extra careful here to make sure that I actually get a decent solder joint. Let's see, moving on here, we have another 100 nanofarad, and then we have a 18 picofarad cap that we need to get. So we'll go for the 100. Am I reading that right? Yeah, 100 nanofarad first. I'm really looking forward to working on a couple of Eurorack modules once this thing is up and running, because I have both a Bafaco Rampage envelope generator, which I've been looking forward to using for quite a long time, and I have a oh, who makes those? It's called the Harmonic Engine by circuitbenders.co.uk. I already have the Sonic Taxidermist, which is super cool. I'm gonna make like a little Eurorack effects box here at some point in the not too distant future, separate it from my synth stuff. But I'm looking forward to doing both of those builds with this piece of hardware. Should make it a lot easier and a little more fun. Okay, what do we got? We got another 100 nanofarad slash 1.1 microfarad here. I'm trying to do this with my hair down again today. I like the way it looks with my hair down, but I keep having a bad habit of getting my hair in my soldering iron, which is really not ideal. At least I won't get lead in my hair this time. You know what? I'm just going to do the rest of the 100 nanofarads while I'm here. Got two more of these. I haven't really looked very closely at the build instructions, or rather the build notes on his website and all the parts that are going to be used. I did, of course, go through them in detail when I ordered all the parts, but kind of just taking this as I go. Doesn't seem like that hard of a build, and I did take some time at least to look at the board. Wow, we got a lot of these 100 nanofarads. This must be either decoupling or some sort of power filtering. Oh, nice. This part of the build is going to go really fast today. Much faster than the resistors. Let's see. Okay, any other of those? Yep, one more there. And another one there. Let's put these all in right now. I'm making sure to spread the leads underneath the board as I put these in so that they don't go tumbling out when I flip this thing over. And then I got two more. I really wish that I could play music on the stream while I was doing this. Some people had mentioned that they've had it on quietly in the background and not gotten any takedowns, but I'm usually simulcasting to Twitch and YouTube and Periscope, and they all have slightly different rules, but YouTube in particular is especially conservative about like being able to, that's 10 picofarads, 10 picofarads. About people being able to have music. I've had streams taken off just on pattern matching that weren't even from music. Oh, one more. All right. I do think that's all of them. All right, let's get this solder on. Go in here with the flux. You know, I mentioned at the start of this build that I usually can't be bothered to clean the flux off of boards that are mine. If I'm doing work for somebody else, I always clean it up. Just the professional thing to do. But now that I'm doing this and I'm seeing it all over the board, maybe I will clean it up afterwards. Make it nice. All right, let's get to it. It's like the pads on this board are, it's like the solder mask is thick enough that the pads are down there a little bit, and you kind of got to get pressed in there with the soldering iron or you don't actually make contact with the pad. I have some new, that way too much solder on that weld. I have some new tips coming in for this soldering iron soon, and another stand so I can not have my desoldering iron kind of sitting up on the side. Okay. I'm also not, this stuff doesn't flow quite the same as leaded solder. But then I'm not breathing in lead. That's it. So we'll get all these trimmed off. Then I will go check in on the chat. Did I miss two? I did miss two. See, this is why I typically don't go with a bunch of parts all at once and try to solder them. The leads get in the way and it's hard to see, but it is faster. These didn't even get flux. So you really got to push down with the iron to get it on the pad. Honestly, I work with a lot more older boards than newer boards. I should probably be using a slightly smaller chisel tip for this one. But I'm typically working on stuff from the 80s or 90s. sell those. All right, let's see how we're doing in the chat. Yeah, last time I had mentioned some videos by a company called Pace. They make a lot of soldering equipment, but yeah, they have a YouTube series that is old videos from decades ago. But they're really good basic soldering tutorials. I'll put them in the chat one more time, just in case you're interested. Oops. There we go. Hey, Cece. And hey, Edson. Yeah, IPA is not as accessible as it used to be. You can actually probably see, let me switch. If you look behind me, I have a Formlabs 2, and I have the wash and cure, but unfortunately, buying IPA in bulk, which I need, several like 6 gallons of it, and it cycles through pretty quickly. It really gets logged with resin. It's really not practical anymore. So I've been looking at moving to a process where instead of using IPA in the wash, I use a detergent mixture in the ultrasonic cleaner, and then I need to source some TPA for the form wash. Because the idea is that you can pre-wash in the detergent and then finish it in the TPA. And then you put it through the curing. And that should be largely equivalent to the isopropyl alcohol process with the cure and the wash. But I haven't been able to source any TPA yet either. So I'm kind of like right in between. Like, I have the equipment that I need to do the detergent ultrasonic step, but I don't have the TPA to do the finishing wash. So I'm gonna have to get back on that at some point. Thankfully, I haven't needed to 3D print any parts for a while. But yeah, we're a little bit. When the quarantine hit, I realized very quickly that it's great to have a 3D printer in a crisis, but that thing becomes a giant expensive paperweight much faster than the extrusion-based additive printing methodologies, the filament printers. So it's very cool for making specialized complicated parts, and I do like it for a lot of reasons. It's still very hard to use, and you have to do a lot of tuning to your models. And it probably has the most annoying post-processing of the other 3D printing methods that I've tried. I'm looking forward to trying sintering at some point. I haven't had a chance to yet. That equipment is still pretty expensive. Maybe at some point I'll have to order a part that does it. Anyways, back to the task at hand. So, perfect. Let's see. Let's go with these other capacitors next. We have 10p. I think there's several of the 10p's. So that's going to be 10 picofarads. So let's put the 100 nanofarads back in the bag. Get them out of our way. Let's see, what do we got here? Those are 1000 picofarads. These are just all the parts from the order that included the parts from this. So I have some parts in here that are just general parts for other projects as well. This is 1 picofarad. I think we have a 1 picofarad somewhere. Nope, 10, 10. We have a 10 and a 10 and a 1 nanofarad and 2 10 picofarads. Actually, I gotta admit, I always mess up the conversion between nanofarads and picofarads. One nanofarad is 1000 picofarads. Yeah, that makes sense. So we do have one of those, and it is that. So where did I see those? 1,000 picofarads. I was talking last time about how there's all these different ways that they package components, and that when you're buying parts on Mouser or DigiKey or Aris or whomever, that it can get kind of overwhelming filtering everything down so that you can tell which part to buy. And this is kind of an example, right? This is like all loose in a bag. This is tape and reel. And then this one is in a tube. So once you kind of get the hang of like knowing what those are and if that's important to you or not, it becomes a lot easier to filter down some of those parts. Let's see. Okay, so put this itty bitty 1 nanofarad slash 1,000 picofarads into the board. With some practice, you can kind of like see the solder joint and see how good of a job you did. Mine are not that great. I know enough to know how bad my soldering is. But yeah, you kind of want to watch how it beads up to see if it actually set on the pad or not. Okay, so we got those, and so what do we got left capacitor-wise? We think we just have these 10 picofarad, 10 picofarad, 2 10 picofarads. We do have one more of those 1 nanofarad right down here. I really like that you don't have to use electrolytics for as many applications as you had to in older stuff. The multi-layer ceramic capacitors are much more reliable than the ones that have the magic goo and invariably leak over time. But you do still need electrolytics for some things. Okay, we're done with these. And let's look for these ones. These are 18 picofarad, this one, right? 1 microfarad. Picofarad. Did I miss it in the box? It says 18. Is that 18 or is that is 18? That is not 20. Or 10 rather. So maybe that was it. 18. Got it. Those are really close to the edge. Okay. Am I missing any? Looks looking good. Suspending these leads. Okay. Okay, just got 4 of them. Oh, this is going to be a little tricky to get in here and do with this iron. Come on. No, this is going to be a mess. This is where I could really use a smaller tip. Really gotta try to push it just at the right angle to get it to touch the pad. Okay. Do you have any other unexpected small ones here? We can move on to, let's move on to diodes next. We do have some electrolytics, but those are, they kind of go in order of like, oops, almost forgot. Almost forgot to put the spares back in here. All right. Making good progress. I think we already filled in half the stuff we have left on this board. So let's go check in with the chat real quick. Okay, I'm going to start with the diodes next. I'm going to have a drink of beer first. Much better. And yeah, I'm going to get the parts that we're not using out of the way. Okay. And let's start with this. So we have a 1N5819 and a 1N4004. What other diodes do we have? This diode is unmarked. I'm going to have to look that up. It just is referred to as D1 on the board. It might just be a super normal diode. Okay, so let's do these real quick. 1N5819. What do we got here? This is our 1N4004, and this is our 1N4148. That's a resistor network. Let's see. One N4001. Yeah, we're gonna have to look up what that other one is. And I must be missing one. 1N5819. Alright, let's do this in the 4004 first. Typically when I'm doing repair videos or mod videos to pedals, I have already spent a lot of time studying the circuit, reversing it, generally speaking, getting familiar with it before I am making a video about it, because I kind of have to go in there with a particular idea in mind about what I'm trying to accomplish. And for this, because I'm building another module someone else made, and because I'm using it to debug, I'm not using it as like a kit that I'm trying to reverse engineer. I don't have a lot of insight about exactly what every part is doing in detail. I mean, I can tell you that, of course, some of those capacitors look like decoupling. There's a couple of resistor networks that I'm guessing are doing analog to digital. I can tell you some things about the microcontroller once we get to that part of it. But I'm, of course, not going to be an expert in the actual design of this board, because I have not looked at its schematic. But if you stick around for some of my other streams in the future, where I'm getting into stuff on pedals, or probably when I do the harmonic engine as well, I'll give a more thorough and thoughtful breakdown of exactly what's happening in the hardware. It's strange that it goes up to D9, and I don't see that many diodes. Where are those other diodes at? That's D1. Where's D2? I really don't see it. Super weird. Well, we'll figure it out at some point. Alright. To the 4004. Come on. I believe these two diodes are here as a rectifier. Yeah, looking at the way that these are aligned, they are different parts, which would be a bit strange if it was like a half-wave bridge rectifier, or a half-wave rectifier, or a bridge rectifier or something, but having two rectifiers next to each other in that order makes me suspect that this is probably some sort of like, it's converting some sort of alternating current to a different wave shape or direct current. It is right next to this, what looks to be a power MOSFET, so that, and what looks to be a power filtering capacitor, so that is probably not a bad guess. One of the things that I like about building stuff or modifying stuff, but also about watching electronics teardown videos, Big Clive does. If you're looking for someone who does electronics teardown videos and, like, I don't know, doesn't suck as much as EEV blog, Big Clive is pretty cool. His level of cringe is much lower than our Australian friend. And I've learned a lot from that, because you get to kind of see how there's design patterns in a lot of this work, and manufacturers will follow certain patterns, certain variations from the data sheets, certain manufacturing templates that are repeated over time, and helps you kind of familiarize yourself with what to expect when you're looking at a circuit. Okay, so that looks like both of those diodes. Now there's this D1 diode. Let's take a look real quick. I'm going to go over to his website, and okay, there's his BOM. How do I see what D1 is? There's his bill of materials. And there's only one other diode. It actually doesn't It's not explicit about this. I might have to just take a best guess. Yeah, it's really not labeled. The 819, 4148. Okay, so it must be this. Essentially what I'm doing here is I'm just looking at the parts list and figuring out which of the diodes that I haven't placed yet into the only diode that I see left on the board. I don't love doing it this way, but well, I guess if there's something wrong, then I will learn something in the process. That's gonna be this, right? Yeah, and you know what? When I had gone by it, I was like, I bet you that's just a bog standard diode, and not a Zener or anything weird. And it is the normalest diode that you can pretty much go for. So, if you're not an electronics nerd, so like a resistor resists, like a resistor is going to like slow the current, and a capacitor is going to store charge according to its amount of capacitance, right, in microfarads or farads or what have you. And then a diode lets the current through in one direction only. I'm trying to be careful about my usage of current versus voltage here because, like for instance, current doesn't pass over a capacitor, but it does store potential. And then a resistor is a current limiting device. And diodes prevent the flow of current up until the breakdown voltage, and then they will allow current through in one direction. If current is attempting to come the other direction, it will be resisted until that has reached the threshold or breakdown voltage, at which point it'll just go either way. Interestingly enough, there's a simple oscillator that depends on the implementation. The implementation is built on the idea of the voltage getting to a certain point and then being able to avalanche past the breakdown voltage of the diode. Sam of Look Mom No Computer did a video quite a long time about specifically building something around that, design. Really cheap way to build a very, very rough oscillator. I wouldn't expect to be able to tune it super well. Okay. That seems like all of those parts. So let's do the electrolytics next. Let's see, we have a couple of 4.7 microfarads. One, two, 4.7 microfarads. Again, this is not labeled. I don't know what C26 is, dude. Or C28 or C27. I really wish that you would tell me. Let's do the resistor network while we're here, actually. Oh, they taped this bag shut. It's annoying. Come on. Now you do have to make sure to install resistor networks in the right direction. And that is going to be, the dot is going to be where the 1 goes. So the dot is here. Just like that. Now, this is a little tricky because I can't like just bend the lead. So what I'm going to do is I'm going to bend the last and the first pin in opposite directions. Bend them down towards the pad. And that's going to hold it in place. Cool. Let's see, these are nice larger pads too. This should be a lot easier. Oh yeah. Easy peasy. Ooh, flux going everywhere. Come on. Okay. No trimming required. Alrighty. So let's do the capacitors we know first, I suppose. I'm gonna take another look. Let's see if I can find some more information. I really don't like flying blind on this. This is 100 microfarad. That's going to be the C9. Again, these are polarized parts, so the black stripe is negative. It goes in just like this. Any other capacitors on this side that are of that value? Need those two 4.7s. I gotta find out what these other freaking parts are. Let's take another look real quick. Yeah, normie diode. That's the bill of materials. I'm just scrolling through this website trying to actually see if I can get any additional information. You know, he's on Twitter. I should ping him at some point and be like, hey. Oh, here is. It really, really doesn't say. Is there a schematic somewhere? Maybe? Ah, this is a copy of someone else's GitHub project. I did not know that. Well, I just found its software and I found its schematic. Ah, nice. Okay. Now we can actually... Is there a board layout? Okay, let's figure out what is C26. Well, that's for version 1.0 as well. So is there... Thank you for your patience. I'm glad to check my work. This is for V1. Hopefully it hasn't changed too much. Okay, here it is. So C31 is 22 microfarads. C29 is 47 microfarads. And then what does that look like on the other side here? Just double check all that. Oh, that's where those other diodes are supposed to go. That isn't even labeled in the silk screen. Okay, so we do have some more diodes. And we have a couple of capacitor, or we have maybe one capacitor. I'm really glad that I found this schematic. I'll put a link to the actual, the originating project in the chat. Learning as we go along. Okay, doke. So, back to where I was. Let's finish with this capacitor business first. And how does it label those? 4.7 microfarad. 100 microfarad, is that right? Sure is. Okay, so let's do these 4.7s. Those are trimmers. These are the ones that I was just working with. Trimmers, what is this? 4.7 microfarad. So we got two of these. No, these aren't. That's super weird. These not. They have a longer lead. So these don't have the typical stripe on them, but one of them has a longer lead than the other. Yeah, usually the positive leg is longer. So we're going to have to orient it with that instead. And there's the other one. Okay. Alright, let's start these in. I'm going to try to be paying an extra amount of attention because these are a component that you do not want to get any hotter than you have to. I think of electrolytics as just kind of frail and easy to break in general. Even though in practice they're actually they're a lot tougher than people give them credit for. Come on, there we go. Boom. Okay. Now let's take care of these components on this side because this isn't on the screen, the silk screen, and I'm pretty sure that these parts need to be populated, and it seems that the build included the parts themselves. So just give me a second here. I'm gonna pull up this. I need to set this up to where I can do some screen capture and I can kind of show you what I'm looking at. Let me actually let me double click and I can just kind of show you what I am comparing between if my poor laptop can hang in here. Okay. Well, I was going to show it, but my laptop seems to be not at all amused with how much we have going on here. Let's try that one more time. There we are. Do I not have the software installed? See, this is, you have my appreciation for being on these earlier streams where I don't have everything completely down. I really thought that I had that installed. Apparently not. Okay, well, in any case, I did put the link in the chat, and my laptop is begging for mercy. So I'm just gonna look at this screen right here and see. Okay, so we have, what are these other diodes that we have here? We have a 4004 and a 5819. So let's go back down here. Okay, not those ones. These are the 4004s. What is this? 5819. Okay. Diodes, part 2, electric boogaloo. So how is the layout of this board comparing to what I'm seeing? So I see this is for a different version of this board. Maybe this is not a good reference. Oh, I really wish that they made this not so difficult. So that's, yeah, this is for a different variant of the board. So I need to find who made V2 is the question. Let's check out the GitHub. See if we can find anything in here. Module tester. Yes, I found it. VO2. Here is the actual GitHub. I will put this in the chat as well, in case you are interested. Okay. So I'm currently in the process of trying to figure out where I can find the instructions necessary to finish making this thing. Because there's a bunch of stuff that's unlabeled on the silk screen, and I did find a schematic for v1.0, but clearly there have been changes since then. So, yes, this is where that module goes, and then there's these two. That is what's changed, is the power supply circuitry. Okay, so maybe those diodes aren't necessary because of that, but I will need these two capacitors. So let's take a look. Oh, and there's an enclosure with some 3D printing files. Ooh, I will probably 3D print my enclosure then, if it fits. Let's see. This is going to require, do I have KiCad installed? I used to. I use Eagle nowadays instead of KiCad. But if I gotta open the files, I gotta open the files. Let's get this downloading. Hopefully this doesn't interrupt the stream. I do have my laptop, so last time I was streaming, my laptop started to cut out at the end, and it was because the Wi-Fi was not holding up, but now I am, oh, it's a whole gigabyte. Okay, it shouldn't take too long. We'll move on to some other parts while we wait. Let's do these trimmers while we're waiting. So, what do we got here? We got a 20K and a 5K trimmer. So, which one is this? This is our 5K. So a trimmer is a variable. Oh, that is the wrong layout of trimmer. That's going to be for here. Trimmer is just a variable potentiometer. So it lets you tune the values in circuit based on whatever calibration regime you have. I'm going to try to get this placed in here. it has to line up just right. Come on. There we go. That's going to adjust the contrast for the LCD. I'm guessing that this offset and scale has to do with the signals that this thing makes. Probably going to require a calibration routine. Come on. And then we got a 20K. It's going to be this. Yep. In there. Bending the outer leg slightly. Perfect. Oh, and our download finished too. If the stream gets a little choppy while it's installing, I apologize. Let's see. And I'm going to download guess I'm going to fork this repository on GitHub. Oh, of course, now it wants to verify that it's me. How did it send that to me? Oh, it wants me to actually use a... GitHub is high tech now. Probably keep this off camera. Oh, I don't have a 10 key. There we go. I'm going to fork this repository. Let KiCad install. We're multitasking. And then I'm going to run GitHub on here. Give my browser tabs a break. All right, KiCad's installing. See, wouldn't this be more entertaining if I had music on? Almost there. One more time. On the plus side, now I will be able to build the firmware myself as well. There it is. KiCad's installing. Hopefully the stream doesn't get too choppy while I'm doing this. Oh, it's a little choppy. It'll clear up shortly. Thanks for your patience. Alrighty, so let's get back to soldering. We got these trimmers to do now. I'll get them with the flux first. We're getting to the exciting part soon, where we can start actually installing ICs and jack sockets and knobs, and it's going to start to look like an actual thing. When I'm soldering, I typically go from top to bottom if I can. Done. Get out of there. Okay. Trimmers are installed. How's our... Oh, KiCad is really still going at it. Was not intending to install a CAD program while I was trying to do this build today. Let's move on to other parts while we're waiting. We got some LEDs. We'll do those in a little bit. We got some sockets to install. This is the LED. The LEDs aren't labeled for polarity. I'm going to need KiCad for that too then. It's annoying. Let's get the sockets installed. A little bin here. So let's see. We got a dip 8. Now I'm going to pay attention to the keying on these to make sure that we're going with pin 1 to pin 1. And again, I'm doing the same thing where I'm just taking opposite corners and bending them down towards the pads. Keep the socket in place. Let's see, that's going to be dip 10. Oh. Keep it. It's not dip 10, what am I talking about? This is dip 14. Okay. The nice thing about when I was doing videos like this as things where I would like record all the footage and then narrate over it afterwards is that, you know, when I'm watching a video and narrating and taking my time, it's a lot easier not to make mistakes and have to correct yourself. What's the problem? Oh, we got one little pin bent. Okay. Moving right along. Okay, that's going to be dip 4. Double checking all my keying. It would be very silly to put one of these in the wrong direction and then misinstall the chip and blow some things up in the process. Although I'm sure that the magic smoke would make for an exciting electro boom moment. but maybe instead of giving you the satisfaction of pyrotechnics, I can give you the satisfaction of seeing a thing work. With any luck, a little bit of patience. Almost there. Okay. Those are all keyed right. And then we got this huge socket, and that thing is keyed the opposite direction. This is where the... Do I have a... Yeah, this is right. This is where the microcontroller goes. It's Atmega 644p. Similar microcontroller to the Arduino. Matter of fact, they probably prototyped this on an Arduino, and that's why it's using that chip. Okay, put this away. And then I guess we can get to soldering. How's our KiCad installation going? Oh, it's only halfway. What an enormous program. Okay, let's do this one first. Kind of going clockwise just so that we can keep track. Get my hair out of the way. Oh, that's really not working, huh? Come on, get on there. I do not like this lead-free solder. Don't think it works as good. It's definitely not full of lead, which is nice, but there was a reason that it had lead in it to start with. That's because it works pretty good. I actually have some new, I mentioned this earlier, but I have some new tips and a new actual heater core coming from my soldering iron too. So hopefully that will make this easier for future builds. Okay, one chip socket, oops, one chip socket down. That one up there. Let's do this one up here. Some flux. Trick is, like, I'm usually trying not to push very hard on the board so that I won't damage pads, especially on older stuff like guitar pedals where it's a single-sided phenolic board, however you say that word. And if you push too hard, you will break the pad right off the PCB. So kind of having to fight my instincts a little bit to push hard enough to get the pad hot. It's still not wicking to the full edge of the pad. Very strange. Maybe I'll get better with it as I keep working with this unleaded solder. Yeah, when I get the tip squared up on the pad just right, then I don't have so much trouble. Wow, it really doesn't melt all the way through though. Come on. I feel like my iron should be hotter, but it's pretty hot already. I have it at 600F, 630F. Okay, that's 3 sockets down. These 3. Let's do the big one. And I'm going to fold down all 4 of the corners on this one because it's such a big socket, and you really don't want this thing floating off of the board as you're soldering. You don't want to like solder 48 legs and then realize that it's not down on the PCB all the way. Now we're getting it down to rhythm. Feels like it takes more solder than normal. Now, if I was soldering on an actual component that was installed and not just an empty socket, I would probably be going in some sort of zigzag pattern because you really don't want to like heat soak one side of the part by soldering onto it repeatedly. But since this is just a socket, we can be a little more, we can go for speed over safety. And the trick is to get in and out in like 2 seconds. One of those things I learned from those paste videos, which is if your technique is good and your soldering iron setup is correct, and there's no other like big factors that you have to be compensating for about the thermal mass that you're soldering into or whatever, that you should really be getting in and out in 2 seconds. You don't want the iron there for a super long time because it's just gonna, the heat is just gonna travel further and further through the board. Okay, that looks good. Oh, we're making smooth progress. So we have this dip 4. Whoa, excuse me. I was soldering and I noticed that I pushed in the tip of my soldering iron, which should not be possible. I am looking forward to getting a new heater core and a new tip. That set screw is in pretty good already. This thing, I bought this soldering iron, this whole paste rework station used on eBay for like really cheap compared to what it sells for new, and it is certainly well used. Likely, I mean almost certainly from some sort of commercial shop. If I remember correctly, it was a TV repair shop that was selling it on eBay. So, but anyways, this thing is built like a rock, but it is quite well used, and I think that it's well past due to replace some of the consumables on it. I also bought new filters and glass tube and rubber grommets for the desoldering gun. That's part of this kit, which I really quite like. It should really be holding in place better. There we go. I have a board vise as well. It's a really nice one. I think that it was someone on Twitter actually who invented it. what is it called? It's called Stick Vise. But it's holding my microphone at the moment, so I cannot use it on my bench. There we go. Those are all the sockets. Keyed correctly. Soldered in flat. Good stuff. So, it's still installing KiCad. Holy shit. Well, we'll go ahead and let that keep running. We have a couple of other miscellaneous parts to install. We have a 20 megahertz crystal, and we have a couple of well, let's see. One pretty bog standard transistor, 2N3904. It's just a standard NPN transistor. And then we got an LM4040 that's a voltage regulator. So let me go in my parts box. There's our 4040. These are our LEDs. We'll use those soon. And what is this? .904 and our 4040 voltage regulator. Okie doke. So, moving right along, and we are making pretty good momentum. Yeah, the stick vise is pretty nice. I like it a lot. I do like this, that this gets it up at an angle. I find that if the board is completely flat to the desk, that it's harder for me to get the camera to see it without a bunch of glare from the light off the board. But at an angle it seems to work a lot better, but for just comfort of working, the stick vise is really nice, and you can kind of throw it around, and people have even modified the grippers on it to be thermally safe for reflow, which is super cool. So yeah, this is the 3904. This is the 3904, and it's going right in here, just like that. These leads up. And then we got this 4.1 volt voltage regulator. This is the LM4040. Just fanning the leads a bit so it'll slide in nice. Speaking of the parts made on DigiKey, I'm sure that there's a version of this part somewhere on DigiKey that has the leads formed in exactly the footprint that I'm dropping it into, but this worked more than well enough. Cool, let's solder those down. Edson had mentioned that perhaps the reason in the pace videos that they were going so short was because of the copper cladding on the boards. And that could very well be the case. I mean, you know, these boards are copper cladded underneath the solder mask, of course, but the layer thickness and some of the other specifics of the board fabrication back then in the 80s or in the 60s was, of course, quite different than what it is today. You know, you're really trying to, you don't want overly thick planes in your boards because of inductance. I mean, unless you're needing it for that for some specific other reason based on your design. Cool. Those are all good. And let's do the diodes. But we don't know. I mean, I could look. Okay, so those all go to the resistors. And then what? The bottom leg is tied together, right? Yeah, it's tied together to the ground plane. I mean, I can guess, but I would really like to. Let's take a look here. What? I went to clone a repository, and I was pretty sure that it was done, and apparently it was just giving me an error. KiCad is nearly done, and then we will know which direction we need to install these LEDs. Okay, cool. This. It's still going. Let's do the crystal while we're waiting. Here we are. Hey, KiCad just finished installing. Okay. Install this crystal. I'm putting this back up a little bit now. Oh, I forgot to solder one of these little sockets. Oops. I do remember putting flux on it. Hopefully the flux isn't totally dried out. This unleaded solder is so weird. It flows so weird. Okay. Wow, we're getting pretty full with this board. So there's a header to install. Well, we'll do the LEDs, and then we got the knobs and buttons and the display, and we get to put chips in. Hey, we're getting to the exciting part. Okay, I am just pulling up the, going to give my laptop a bit of a break here. There we go. Okay. CD. And we want to open the board file. Just catching up on the chat. Let's see. Let's see. Okay. Oh, ironically, I tried to open those and I tried to open them in Eagle. Are these Eagle files? No way. Yeah, they were indeed KiCad. Hmm. Yeah, replying to CC. Yeah, I mean it's cool. It's cool like to be able to like rapidly prototype with the proto board or with breadboarding, but it is nice to have a PCB. It does certainly make it faster. Okay, so here's the board. Here's the PCB file, but there are no. This does not seem like a valid piece of data. It's very strange. Let me open up the schematic. It would be nice if there was just documentation, but no such luck. This is blank too. Do I not have the right module library? But I should be able to at least see the parts, huh? Why does this look totally blank? Oh, because those aren't the actual files. KiCad made some files that were named very much like You know what? Maybe this is an Eagle project. It would be ironic if I went through all that hassle of installing KiCad under the assumption that the GitHub project used open source tools, but I could have very easily been wrong about that. Launching up Eagle now. KiCad's a pretty good program. I am using Eagles mostly because I was taking advantage of the integration with Fusion 360. They have their pros and cons. Apparently they changed something recently in the integration that people are not at all happy about, but I've not personally been running into it. I love to have to use a text message to authorize my CAD software. Okay, let's open up this board file. Is it gonna work? Yay! Okay, that's the schematic. And here's the board. Okay, I finally have the information that I need. Okay, first of all, those are 100 nanofarad capacitors down there, so that is going to be those 0.1. Right here. So it's these. Yep. Now it has these on down here as electrolytics, but I don't know that these would need to be electrolytic. I'm not sure why they would do that. Maybe I'll hold off and double check the build list before I do that one. Let's take a look at these diodes. So I'm guessing that they're also not labeled in the silkscreen here, but I can at least see in the schematic how they're intended to be wired. Let's see. Those are switches. Those are capacitors. Okay, so it's going to be, looking at the schematic here, it's going to be the anode side that is going to the resistors, which are over here, and then the cathode is tied to ground. That makes sense. That's pretty normal. So we're going to take the long leg towards the top on all the LEDs. Okay. And I'm just going to look at them to double check that I have them oriented correctly. With a bit of practice, you can look at the inside of the LED and tell which is the anode and cathode. One of these leads was bent, and I almost put it in the wrong direction because I thought that I got the long and short lead mixed up. But they're all good now. Now I kind of want for these to be like really flush. So I'm gonna pull these leads extra taut. Yeah, that looks better. Okay. Come on. really have to get in there to get to those pads. Okay. Remember when I mentioned the first time about getting a decent set of diagonal cutters? If you can afford it, you will not regret it. Okay, those are in. Now, what else did I want to double check on? It was mostly about all the components here. So I'm going to go back to that board layout and take a look. Okay, so there's supposed to be a capacitor right there. That's on the opposite side, right? Yeah, that's C26. $100. In the build list on, I'm going to go back to his bill of materials. Come on. Yeah, there was no electrolytics in the build list. So I think that we're just going to use these MLCC capacitors, which personally I'm totally fine with because I find that they're more reliable in any case. I've replaced a lot of electrolytics and pedals with these MLCC capacitors. I've been pretty happy with the results. Do I really want to do that on the opposite side? No. Because this isn't because polarity isn't important here, I'm going to keep it coming out the top. And then what of the other two? Same. Cool. And these are tying what I'm assuming are voltage rails out of this power regulator to ground. Yeah, that is certainly what it looks like. So these are probably decoupling capacitors. So it's not. Well, we get to test the thing I said in video in the first part, which was that if you're trying to buy decoupling capacitors and you're not sure which part to get, that as long as you're within the right voltage tolerance and you're having the right amount of capacitance, that probably not going to make a huge difference unless you have a very sensitive application. If this happens to be one of those quote-unquote sensitive applications, you will at least get to have a good laugh at my expense and then see a video where I understand the nature of that problem and then get the right parts. Okay. Great. So we don't have those other diodes because this one uses this voltage regulator module. I'm thinking we should probably install the voltage regulator module now. So that is going to be this huge thing, which I only bought one of because it's like 20 bucks. So I am going to mount this on the side that's lit. Oh, nope, that ain't it. That's heat sinks. We will use that in a second. I'm going to put this away. LCD. There we are. There it is. One chunky boy. Big old chunky thing. Drops in just like that. This, I don't want to get too crazy with bending the pins on. So I'm going to bend this pin just a little. I'm going to bend this pin just a little. Then I'm actually going to kind of hold it in place while I'm doing this. Okay, there we go. Once I got the first ones in place, we're fine. And this one I will do the zigzag to kind of balance the heat over the module. No problem. Sweet. Alrighty. We got that. So, we are in the home stretch. Let's do... Let's do the jack plugs next. Actually, no. We'll do the jack plugs nearly last. We're going to clear my bench real fast. Put these LEDs away. We're gonna do the power transistor, or there's a couple of MOSFETs we gotta install. These are all good. Those are all good. That's good. Those are those pieces. Okay. So we got those. What's this? Okay. We got some buttons. What is this? Our LCD. We'll leave the ICs for very last. Header, transistor, and one other set of headers. Okay, next round of stuff. So that's our Eurorack header. Only need one of those. And again with this one, I'm going to kind of like, because I don't want to bend these really rigid pins, I'm going to kind of just hold it in place with my hand as I tack the corner leads down. Just double check on my streams, see how everyone's doing in the chat before we get going here. Thanks for hanging around and watching still. We've been going for, geez, almost 2 hours now. Get this board recentered in the frame here. Let's see. There you are. And yeah, let's get this rolling. So say the thing about soldering is that you need 3 hands, and that is absolutely true. Woo, that got warm. I have burned myself so many times while soldering. It is a thing that just happens, especially if you're kind of clumsy and impatient like me. I've been thinking a bit about how we want to do the bring up on this. Like, of course, the obvious ploy is to get all the parts in and then turn on the power and see what happens. And this was quite a lot of parts. I don't want to just release the magic smoke. So we're going to do some basic diagnostics in the course of bring up. Probably going to at least poke around for shorts and... Oh, was that header supposed to go underneath? And that's how it's labeled there, huh? If it's supposed to go underneath, and I put it that way, how will it need to be oriented in order to be correct? Why would they put that underneath? I guess because you would... No, I want it on the top. This will be fine. I just got to make sure that I orient the cable correctly when I plug into it. I've always had a frustration with the Eurorack standard because how'd they just change the output of the pins? And I'm not sure if they did it for like noise cancellation or like, I don't know, like interference issues, but they could have made the pins reversible. And a lot of Eurorack gear has been fried over the years as a result of that particular issue where if the pins are backwards, you get a pretty gnarly short. Okay, these are bent right at the... These need to be bent just like that, right at the base of where the pin gets a little narrower. And then this is going to have that heat sink too. Let's take a look at the heat sink real quick. Okay, come on. Get in there. Okay. CC, if you're still watching, I hope your pedal project is going super cool. CC is making a combination rat fuzz pedal and was showing me some awesome literal old school breadboarding, like wire wrap on a plank of wood level breadboarding, which you love to see it. And yeah, I hope that their project is going well. Looking forward to hearing those tones. And then this heatsink goes in like this. Did I leave enough space? Maybe. Ooh, it's gonna be tight. Yeah, that should be fine. Just like that. I have screws somewhere. I'll deal with that later. Okay. Power transistor is in. It's pretty surprised. It must be because they expect the modules to be able to draw a lot of wattage. Alright, we got another header here. This time we're going to install the header the way that it does intend, which is from the top. And if you've been typing in the chat and I haven't been getting back to you right away, thanks for being here and thanks for chatting. I will stop over in a second and say hi. It's always a balance between like keeping it interesting on the actual stream and for people who are watching the archives later, and also making sure that I'm interacting with my friends and my viewers. Whew. It's always risky with that thing where I hold it in with my hand, because if I take too long, it will burn the crap out of my finger. Okay, header is on. Making good progress. Now we have this thing, our jack socket. This really is not, it really runs out of heat momentum. Gonna have to revisit my soldering iron temperatures for this lead-free solder at some point. Do some tests. Come on. I'm gonna wait till I get my new heater core though. Okay. Hey, we got a jack socket. Sweet. Add the plug. Yeah. So, yeah. Nice. Good shit. We got another plug there. It's not a jack socket. Let's see. What is this? That's the LCD. We'll get to that in a minute. Those are the headers. We're done with that. Okay, let me dig into the parts box real quick. Figure out what this other plug is. And then we got a DC jack too that we need to install. So, yep, we need that. So we're getting to the end of the build, and I'm not sure what this is. That it's not two of those. I gotta find out what that is. I'm gonna have to look in the schematic. And we have our DC power jack. We're gonna get a lot of solder on this one. I gotta really fill this one in. Okay. Just need to get that tacked and start to fill in this big one. Come on. Ooh, it needs a lot of solder. Definitely not doing the 2-second rule on this one. Okay. Hey, we have a power plug. Nice. Nice, nice, nice. All right, let me have a drink of my beer and check in with the chat. Yeah. Word. I'm glad that CC's project is going well. CC, when you get it further along, you'll have to share online. I'm really looking forward to seeing it. And yeah, it's always like a trick to be able to figure out like what parts do you need, and as you're prototyping it, kind of moving on, and especially with the guitar pedal, because like how exactly you want to approach like any pre-emphasis or de-emphasis that you might do, or approach the buffering, as you had said. Like there's a bunch of different ways, and there's some common design patterns, but there's a few different ways to do that as well. So part of the fun part is to prototype around, but of course you need all the parts on hand to do that. Okay, I'm gonna go back to this schematic. What is that? Is a MIDI jack. Oh, that makes sense. Yeah, and I didn't buy that because I have a ton of them. Are they? Excuse me while I dig through my parts. Where is my box of MIDI jacks? One moment, please. Knob, that's the power supply. Oh, I know that I just saw those. They were here for the longest time. This is me being unprepared on the stream. What did I do with my MIDI jacks? They should be. They must be down here. One second. Got parts everywhere in here. Some Nori's Electronic Emporium of unorganized crap. Where did I put those MIDI jacks? I guess we don't need them right now. And I didn't buy more of them because I knew that I had a lot of them. Oh, they're in here somewhere. Oh, you know what? I got one right here. Pull it off my proto board. Okay. I had bent these little pins a little bit when I put it in the proto board. Come on. Okay. Perfect. This I can bend these pins a little bit. They're just there to anchor it. Get some flux on there. Ah, annoying. Gonna have to hold that in place maybe. Okay. Wow, it really does not go to the pad. There we go. Really got to push on these pads. Okay, boom. We got a MIDI jack. Hell yeah. Making solid progress. Alrighty. We're getting, those of you who have stuck around, we're getting pretty close to the best part. So, let's see. Now, for these buttons, now I did have to go kind of off the reservation. I shouldn't use that term. I did have to like do some homework of my own to find buttons that actually worked. The buttons that were in the BOM are not available and extremely backordered. So I did some of my own homework and found I'm just making sure that these buttons are... Oh, my multimeter's in the other room. These don't have any kind of indication of... Yeah, this should be fine. Oh no! Shit! Oops. Slow down and pay attention to what I'm doing. Kind of got to like pop these in here, and I had one that just like bent the leg instead of popping in. Anyways, I had to do some... Ow. Woo! Yikes. I had a hard time finding the buttons for these that would be in the right footprint, and I'm squeezing the board right where it comes through and pokes me in the finger. CZ, I'm glad your thing's going well, and I'm looking forward to it, and you are more than welcome to ask me whatever questions you like. I am happy to help. Likewise, if y'all follow me on Twitter, at NBLenore, E-N-B-Y, Lenore, L-E-N-O-R-E, same as my Twitch, same as my Periscope. But if you find me on there and you have any questions about, I don't know, any electronic stuff or any stuff I've been working on or your own projects, I can't promise that I'm going to know the answer to your question, but I am happy to do my best to help you. And thanks again for hanging out and watching the stream. Ah, shit, I missed another leg right there. Alrighty, desolder and wick time. First time I've had to do it on this board so far. I bent down one of the legs. I actually don't think it matters, but I'm not going to take the chance. Come on, get off of there. Oh, I extra hate this unleaded solder now. Come on. Almost burned my finger. So the trick with braided solder wick is you really got to flux the wick. You want the wick to be the place that the solder wants to live. You got to make it the most attractive place to hang out for the solder that you possibly can manage. And then it should pull the solder up into the wick for you without you having to like drag the wick too much. But of course it works. It works just straight up worse with lead-free solder. Sucks. Cool. Can I get this button out now? This is so hard to grab onto. Yep, there we go. Come on, get out of there. Frick. this sucks. I need to just, yeah, I'm gonna destroy the switch in the process, but I need to just get this thing out. Come on. There's really quite a lot of solder there still. I really wish that solder wick would have worked better. Let's try this again. Usually this stuff works pretty good. I have it down to a bit of a science on the leaded solder, but this stuff is just not that inclined to move into the solder wick. Whew. Careful. The thing I said about being clumsy and impatient. I am going to remove this pad if I keep that up. That part is still in there. That leg is still in there. You suck, switch. I have to let my desoldering gun get warm, but let me flux on here and see if I can. We need to move this back in the camera frame. Do with my lid. Can I? Wow. Oops. There we go. Got it. Woot. Desoldering gun to the rescue. Okay, let's try this again. Wow. I bent up two of my switches. I only have two left. Let's try to not mess any more up. Yeah, some of these legs are just bent further back to start with, and if you aren't careful, you will fold that leg right in. There we go. That's in for real. Alrighty. Let's try this one more time. I am not happy with the way that this solder is flowing. Come on. It's not getting far enough. I'm actually going to turn the temperature on my tip up a bit. Let's see if this works a bit better. Oh, immediate improvement. It's really hotter than I like to run my iron. It's a 650F right now. these are buttons, not ICs, so. It just does not flow like leaded solder. It's so weird. Woo. Okay, there we go. That's all those. Okay. Time for knobs. No, those are not knobs. Those are jacks. Those are jack sockets. And that's the wrong part. What is this? This is a rotary encoder. But potentially the wrong footprint of a rotary encoder, unfortunately. Yeah, this needs to sit down like this. I will reapproach that in a moment. Let's deal with these CV jacks. So, I'm going to dig in here real quick. Uh-oh. So, that is supposed to be double check this part. Supposed to be this rotary encoder that is 90 degrees. Ah, silly, silly, silly me. These are 24 poles. Horizontal, these are vert. Okay, we will have to live without that part. I will have to order this part. So we will install the LCD instead, and then I think we'll be able to actually put in some chips and bring it up. We don't need to have these. I do have these. Don't mind me, I'm just looking for a part. Using a different part than mine, so I'll have to get that one too for the CV. So I will have to order a couple parts, but we can at least get this thing with chips and see if it powers on today. And we should at least get something on a screen, which should be pretty satisfying. Okay. So they have this module, and they don't have the pin header running through it. So what we're going to do, see, they got it like that. I don't really want that pushing up against the board. It's interesting that they, I guess I could have paid attention to that when I was getting the parts. So what we're going to do, okay. Moving some stuff out of my way here. I'm pretty confident that I have some headers which will work. Okay, pretty sure that I have some headers which I can use to stand this LCD off. Because we certainly are going to need that connected in order to be able to enjoy watching this thing boot up. Going through my parts boxes. Trimmers. Header. Where is my headers? They might be down here. Aha. There are some of them here. Dual rank. I need a single rank header. You know, I know that I bought a bunch of headers, and I found some of them, but I don't know that I have any single rank headers. There's another way that I can do this that won't require headers. Just looking around on my bench. Okay, we're gonna do this. We're gonna do this the old-fashioned way then. There's our display module. There's our pin 1. There's all of that stuff. So, do I really want to do it like this? I think this will be fun. Come on. Get in there. Come on. There we go. Okay, this would be a valid time to be like, Lenore, what the hell are you thinking right now? The answer is I'm going to just put some legs through and I'm just going to solder this thing on in place. Ideally, I would have a single pin or a single rink, an SIP header, but I don't have one, at least not readily available. So I'm going to kind of just, there we go, that lined up. Once I have a couple of these in place, this will get a lot easier. Okay. What I'm doing here is I'm just taking some legs from other parts that I have sitting around, and I'm just using those. Hi, kitty cat. You want to come visit the stream? Meow. Are you hungry for dinner? Yeah. Okay, that is now attached. I just need to put through the rest of these legs and solder them into place. Real improvisational hours on this stream. Okay, so I got a handful of these to do, so just gonna put the lead through, and I'm gonna try to put it through and like, yeah, keep it pressed like this. So I'm gonna put it through, then bend it. Maybe I'll do it like that instead. I specifically don't want it to be coming down sideways. That should be fun. It's annoying. Good old Hitachi display model. Or Hitachi, what is it called? There's a particular Hitachi standard for these displays. Okay. Another one. Another one. Okay. Work our way back over this way now. Also paying attention to make sure that I'm going from the right pin into the right hole. Okay. Okay, 3 more in. Gonna finish doing this top side. So I'll do 3 more on the top side, and then we'll solder all those on the bottom at once. Whoop. Come on. Stay in place. Ooh, this would be easier if I had a freaking header. Come on. There we go. Okay. Whoa. Whoa, whoa, whoa. Had that one soldered on and then it came back up. Okay. Take all these. Okay. Now let's quickly do those. We're making pretty good progress on this. This isn't taking too long. Come on. This is the last annoying step before I can put chips in and we can try to boot this thing up. Just gonna do these. Okay, only 3 left. Didn't make any shorts. Good, good. Okay. Last 3 on the top side. Okay. Somehow these tweezers got, or these needle nose got magnetized. That must have happened recently. Okay. Old school, but it works. Alrighty. Display is attached. Sweet. Pull the little piece of plastic film off. Alrighty. Let's populate the board with chips. This is really the moment of truth. We can go check out our chat here. Got a couple people still hanging out. Hello, everybody. Okay. Can I get this back in frame? We're all good. Okie doke. So, let's start with OK1. 6N137. Alrighty, here we go. So, first, we got a 6N137. This is a optocoupler. That's why it's right next to the MIDI jack. This thing's job is to electrically isolate the MIDI's signal at the wire from the actual circuit. This prevents, when you have a bunch of MIDI gear plugged into each other, this prevents it from like establishing some sort of like common ground and getting all funky on you. So this is pretty much like an LED with a what do you call that? A photodiode. Yeah, photodiode. And essentially, it's it makes the LED get bright. It's kind of similar to a Vactrol, where you have an LED and an photodiode, LED and a photodiode, and then they use that to electrically isolate while still passing over the voltage to connect circuits. Okay. What else do we got here? We got TL047P. TL047CM. This is a very similar part. This is it. Sometimes you don't find exactly the part that you're looking for, and you have to use like a compatible variant and just study the datasheet as well as you possibly can to make sure that the specs are going to support your use case. Come on. Get out of there. There we go. And this part right here is this is a dual operational amplifier. So this essentially just has a handful of separate op amps in it. I think this has 4 op amps in it. I have to go check the data sheet. Makes sense that that's sitting next to the signal mangling. Like I said, if this was a pedal job or something, I would be much more familiar with the circuit than I am with this one. This is a 74HC. That's a 74 logic shift register, right? Yeah, 74HC 165M. Oh, that's the 165N. Okay. So this is the parallel shift register. And that's going to go at the bottom here. Looking at this, yeah, so that's what's going on here. So just to describe what these two chips are doing, come on, fold back in. There we go. This one right here, this parallel 8-bit parallel load shift register, SN74HC165N. This is connected up to the switches, and this is essentially making a data buffer for the Atmega microcontroller, so that they don't have to break out every single one. Essentially, it allows you to have 8 bits of state, 8 pins of state, over here on the other side of this chip, without needing to wire up like 8 separate data lines from the microcontroller, because it puts them into this shift register. There we go. Okay. Yep, and then we have something that's pretty much like, I don't want to say the inverse of this, but this is driving the LEDs. So this is an output. So this is input into the microcontroller, and this is output out from the microcontroller. And this is running all the LEDs. So that's why it's connected to the resistor bank, which are all the current limiting resistors. These resistors here correlate to these LEDs here, and this chip is allowing the microcontroller to drive all these LEDs, but to do so with only a couple of data lines instead of all 6. Okay, that's in 2. All right, only a few chips left. So we got let's see, MCP 4822. That's this right here. This is a digital analog converter. This one's in totally different packaging. Little foam box. Okay. Boom. And I believe that last one's the MCP 6002 operational amplifier. Double check here. Thank gosh I got these Eagle files, because it's making this a lot simpler. There we are. Almost there. Hey, this is looking like a pretty populated board at this point. I'll have to order the jacks and the rotary encoder again, unfortunately. But it'd be like that sometimes when you're doing electronics. Okay. And for the grand finale, it is our microcontroller. Now, noting that the keying on the microcontroller is opposite all the other ones. The keying on the microcontroller is pin 1 is oriented down and not up. Actually, before we put in this microcontroller, alright, we got to do a couple things before we put this microcontroller in. First of all, take a deep breath, have a drink of beer. Let's get some power wired up. So this is going to be center positive. Yeah, this is center positive. And I'm going to need, do I have the adequate leads. Turn on the power supply. I have a little benchtop digitally controlled power supply here. Turn this up to 15 volts. Actually, a better trick is to turn this down to let's say 6 volts, and then make sure that it's current limited at something pretty low. Again, this will help us from cooking it as we bring up the board. Okay, I'm going to grab my power probe. So we'll be back in one moment. Okay, get my multimeter here, and I'm just going to quickly throw this here. Go ahead and test it with the multimeter while I'm doing this. Okay. And there's not a short. Perfect. So we can plug this into the power supply now. Woo! Really intended to have that turned off. Okay, certainly current limited. Let's get this turned up to way too high, way too high, way too high. I would really like to have a better power supply. This is not my favorite. Okay, 15 volts. It's drawing 1.5 milliamps. Pretty good. We're certainly not current limited. Let's turn that way down. I'm just setting the power supply up to some reasonable parameters here. It's been a while since I used this. I set this at 500 milliamps. $15 volts, 500 milliamps. Turn it on. Lights are on. Everything looks okay. So, and what we were checking there is just to make sure that it's not like drawing an insane amount of current, that some diode's installed backwards and it's shorted out, or just nice to do so that you don't accidentally cook the processor once you put it in. And here's the processor. Get it in without bending any pins. All right. It's the moment of truth. Are you ready, chat? You ready to see if this thing actually boots? Here we go. Okay. It's not. Up, up, up. Yeah, it works. Sweet. Now, of course, it's hard to, well, that seems to work pretty good to me. Now, of course, I'm going to have to test all the outputs and actually drive a Eurorack module with it and get these switches and knobs all hooked up. Calibrate it with the offset and scale. Still kind of just tuning the LCD brightness. Well, it boots, it runs, it doesn't use an absurd amount of current. Hell yeah. That deserves for me to finish the rest of this PBR. Well, we have it now. This thing here. I'm gonna get the rest of the parts. I'm gonna order and 3D print the case. I'll post about it on my Twitter, and I'll post about it on Instagram, and just finish up the build. And then the next step is gonna be to start building that Bofako module. I can't believe that all the dodgy soldering on the LCD worked perfect first try. Nice, so lucky. Thanks for watching, and I hope that this was entertaining or interesting. And yeah. We'll see you around the next time.